Hello, everyone. Today, I'd like to introduce you a new project called Spike. Spike is a project under SPIFFE umbrella, and it stands for Secure Production Identity for Key Encryption, which is Spike. It's a secret store that uses SPIFFE as its identity control plane. Today, I go through its documentation, its repository, and I want to set up everything from scratch and also go through the quick start guide and see together how it works, what we can do about it, and how its future will pan out. So this is the website of Spike. It's spike.ist, like a spikeist. I don't know, however you call it. So it has. The site is pretty new, so it's under development, but still there are certain things that you can go and see. There's a kind of an overall system overview, system diagram, what kind of components it has, and also there's a quick start guide about telling you about how you can start experimenting with Spike. As you see, it's still there are missing bits and pieces. The project is pretty new. I just created the public repository today. The repository was private for the last couple of weeks because we were discussing where to put it, how to launch it, and now it's under SPIFFE GitHub organization. Let me open this one as well. The URL for the repository is SPIFFE github.com SPIFFE Spike, and let me see. Spike is a SPIFFE-enabled secret store, and we are trying to align how it behaves to other well-known secret stores like HashiCorp Vault, for example. So it has a key value interface that acts more like how you would use a Hashi Vault user experience. The reason we do this is because initially not to create friction, because you will be as a user more familiar and more comfortable with a API or with an interface that you know and you know how to use. So it uses a similar CLI, but behind the scenes it's different. It's using SPIFFE as its identity control plane, which makes it relatively more secure. So I'll show it with a demo and it will be more clear, I guess. Essentially, Spike doesn't assume any kind of environment. It's not dependent on Kubernetes. It's not dependent on a operating system. As long as there is SPIFFE support, it can run anywhere, including Linux, Windows, and other places, and including Kubernetes as well. And to make the configuration also a global, we are using environment variables, because environment variables are supported almost everywhere. It's easy to configure and it's easier to relatively easy to manage. So that's one of the decisions that we have made. And as the topic of decisions, we have what we call architectural decision records. So whatever we decide, we keep a detailed discussion records about it. So why we choose that way, what we are doing, and this is all open source. So you can feel free to contribute to it, add value to the discussion. And these records are just historical records. They are not set in stone. For example, a while ago we decided to use Postgres as a backing store, and then we realized an S3 Amazon S3 or a Minayo compatible storage would serve at least our initial needs much better. So we superseded that one with another architectural decision record. So things are in progress, and we are transparently sharing everything that we can, including designs, flowcharts, diagrams. To use Spike, you need Spire or something SPIFFE compatible. We'll be using Spire. And to use Spire, you need to one way to do it is to build it from the source. Or you can download the binaries, or if you are in a orchestrator like Kubernetes, you can like just use Helm charts and deploy Spire through Helm charts. But since this is a Linux machine, the way that we can use Spire in this one is to just build it from the source code. So I'll just follow these instructions to see how it is done. But I have already Spire installed on my system, so I am not going to copy the binaries to where they are supposed to be. I'll just create a temp folder, and then just go through the creation process rather than moving them to something under the path. So where am I? Let me check first. Let me create a temp folder, cd temp, and then I'll follow the instructions in the guide, and I'll just clone Spire and cd into Spire. And like if you have make, building Spire is just a single step. You do a make build, and it will create a Spire server and a Spire agent binary for you. I'll just wait for it to finish. Okay, so it's created Spire server, Spire agent, and Spire OIDC discovery provider. So if I do ll bin, I'll see like all of these binaries. So if I do like a bin Spire agent, it will give me like an API about how I can use Spire agent. So I have Spire in my system, and let me open the repository as well. This is the I have lots of stuff open. Let me close them all first. So this is, let me collapse a bunch of more. This is a Spike repository, and it has a config folder down here, and it has sample Spire server and agent configurations here, and the scripts down here, the scripts under this hack folder uses those configuration to initialize itself. So we have a Spire agent starter and Spire server starter that uses those configuration files to bootstrap. I can just quickly go through them, and these configurations are just for like development purposes. If you want to do a production grade Spire deployment, then I highly encourage you to go through the official SPIFFE documentation. You can go and see it at spiffy.io. From spiffy.io, you can go to like Spire or maybe documentation, and then there is like configuration reference and scaling references, and how you can install things, how you can configure stuff. So I suggest you go through those, and also jump into the SPIFFE Slack channel to ask your questions, essentially, because there are in the SPIFFE Slack, there are subject matter experts that can help you. And then you get to go to the SPIFFE Slack, like there is this Slack button down here. You can just click it. It's a public Slack channel, so you can get help. But essentially, don't the moral of the story is, don't consider this as a production setup. It's far from it. Like, it has dummy certificates and dummy configuration to just make a SPIFFE Spire setup running, but that's it. Not much. I have two starter scripts. I want to go through them to show you, what's going on. Then I'll run them. So this is the server starter script. So what it does is, if there are anything from the former batch, we delete them, like the agent join token and admin token. Then we build the binaries, the Spike binaries, which I'll tell about them shortly. Let me show it. So we have, let me show you. We have a keeper Nexus and Spike as binaries, and these uh, lines that you see below are creating, those same binaries in various different architectures. But for the sake of our work, we'll be using these three. So the Nexus, Spike, and Keeper establish the Spike system. So the server starter script builds those binaries from scratch as well to make sure that we are using whatever the source code maps. So we have Nexus. Nexus is you can think of Nexus as the secret store. So if you are familiar to HashiCorp Vault, Nexus is considered as the vault where the secrets are. Keeper and Nexus talk to each other, and they exchange trust materials using MTLS. So Keeper Nexus sends its root key to Keeper, and Keeper keeps it in memory. So what use this could have? For example, if Nexus crashes, then it can ask Keeper to give its root key back. And since this connection between Nexus and Keeper is done through mutual TLS, it is relatively secure, which means as long as we can trust how we identify and how we uniquely and cryptographically verify that these binaries are the binaries that they claim to be, then they can securely share the root key through MTLS, and Nexus can use Keeper as a backup medium in that case. But how do we trust those essentially? To trust those, we use SPIFFE IDs. What are SPIFFE IDs? So for that, I am going to show start Spire. There should be a registration script somewhere. It's here. So SPIFFE IDs are a way to cryptographically attest a binary or a workload that it is the workload that we trust. There are various ways to attest it. In a Linux environment, we can query the kernel off cycle out of band to attest the authenticity of a workload. So for example, here we are making sure that our binary, to be able to get an ID, has to have a certain SHA hash, has to be under a certain Unix path, and it has to be run by a certain ID, a user ID. And there are other selectors that you can add. And if you add enough of these selectors, then the premise is you can cryptographically verify that this is the thing that you are using. Because assume if there's a hacker that wants to deploy their own counterfeit workload, then the SHA hash will not match because it will be a different binary. Then we won't assign a SPIFFE ID to it, and therefore it won't get a certificate, and therefore it won't be able to establish the MTLS connection that I have been describing. And this provides a robust security between the store and whoever is talking to the store by leveraging SPIFFE as the identity plane. So that's that one. Let me go back to the server starter. So what we did is we built Spike from the source, and then next is we cleared whatever extra tokens and join tokens and things that we had. And the next is starting the Spire server. And start Spire server is, let me show you, it's a one-liner. We are running the Spire server with this configuration. Agent starter does similar things. We generate an agent token. Let me show that one as well. Generate agent token. So we use Spire server to create a token for us, and the way that we do that this agent token or the Bootstrap token initialization is done is you provide the token file to the agent off cycle out of band, and that's how the agent and server can trust each other, because as an administrator, I know the server, I know the agent, and I am asking the server to create a token, and I am inputting that token to the agent, which means as long as I am trustworthy, then the agent and server are trustworthy by the linkage of this token file. So this is one of the ways that is done. Like I said, there are other ways to do it as well. You can use cloud identification like AWS IAM. You can use Kubernetes projected service account tokens. There are many other ways to do it. This is the easiest to do it in a demo environment, and that's why I am choosing to follow this path essentially. So let me go back. Spire agent starter, that's we generate agent token, then we create those identity entries, register Spire entries script does it. So what we do here is we say for Spire keeper to be authenticatable in this system, it needs to have a certain user ID, it needs to be running under a certain path, and it needs to have a certain SHA hash of the binary. And we do this the same for Nexus and the same for Pilot as well. What is Pilot? Pilot is the binary that you talk to the system. Again, if you think on in the terms of HashiCorp Vault, it's the command line interface that you like interact with your key value store and securely store your secrets and things like that. So those are that one. I think that's good enough of an introduction. You can go and like check out the source code yourself. And maintainers, right now, Volkan, am the lead architect. Kevin said he would be helping the project as best as he can, but he is like my bus factor backup essentially. If there's something to be done on the repo and I'm not around, Kevin will be there to help you. This is relatively a tiny project in terms of SPIFFE project categorization, and since it starts as tiny, a single maintainer is good enough. But if the project evolves, we can have more core maintainers as well, and also it depends on how much interest and how much support we can get from the community. So feel free to chime in, feel free to add value, and feel free to let this project make the world a more secure place. So that said, let me go to my workspace folder and like start doing a quick demo. I'll go to desktop workspace where my Spike project is, CD Spike, and I'll pray demo gods that this one works, because it was working last night, but it's live demo, anything can happen. And if things happen, it's fine. We'll be debugging it on live stream, which is also extra fun, essentially. So let me see what I have. I'll list the hack folder, and I'll just follow the steps that we have done so far. So I'll first start the server starter, hack Spire server starter. It will build the binaries and it will initiate a Spire server. Let me split the screen. I will need an agent as well. Hack Spire agent starter. It will do its thing and it will start an agent as well. So I need two components, Spike Nexus and Spike Keeper, so that I can use the secret store. So, and if I search in the project folder, let me extend it a little bit. So we have Keeper here, Nexus here, and Spike here, which are all of these are our binaries that we'll be using. So I'll start Keeper first. sorry, I'll start Nexus first. And it will say like, hey, I started, I'm listening, and things like that. And it will try to talk to Keeper, and there's no Keeper here. And Keeper is not strictly necessary, so it will try to talk to Keeper, it will retry, and if the connection is refused or whatnot, it will still try to establish that connectivity. But even without Keeper, you can use Nexus. It's just, when the Nexus crashes, the secrets will be gone. Without Keeper. Or actually, not the secrets, but the root key will be gone, so you cannot recover the secrets without Nexus, at least in this current state. So let me start the Keeper as well to have more resiliency in the system. So these two folks will start talking to each other. I'll split this part vertically too and move this one here. So again, these two can talk to each other. They will chat. I'll just ignore that for now. Our binary is Spike. So when I say Spike, it will say, hey, this is Spike binary. You need to use Spike command. So I want to get secrets maybe. Clear Spike get tenants. What tenant? Acme. DB. I want to get Acme Corporation's DB username and password. And it says, oh, you haven't initialized Spike. Can you please initialize it? So I'll do a Spike init. Again, right now, for the sake of this demo, it's saving the token on the file system. Later down the line, this won't be in the file system. It will be in memory. But right now, it's in the file system, and it is plain text. It's not encrypted, just for the sake of the demo. But like I said, in later phases of the project, this will be in the memory of Spike Nexus, and you can only decrypt it by providing a passphrase. So let's see how the token looks like. Cat Spike admin token. It's like a typical token that starts with Spike and then some secure set of random characters. Again, we have projects to use more common tokens like JOT tokens and other like OIDC authentication and things like that, but those are all planned out. Like, this is just the first week of the project, and I'm still amazed that we could go this far this quickly. So let's see. We initialized it. So let me clear this one and do the Spike get again. No secret found. Okay, let's create one. Spike put. And you might have realized that this interface looks a lot like how you can use a HashiCorp Vault, and it's intentional. Like I said, we want the experience to be common so that you don't have to learn something new just to use a new tool. So I'll do tenants Acme DB username Spike password, I don't know, Spike Rocks, enter. So when I get this one, I can get the password. I can change it when this one as well. But for example, I made a typo in this username. It says a double N. So let's change this one. Username Spike pass. Spike is Arium. So awesome that one S falls out. Okay. Okay, so I need to do put. It's giving me an error. Let's do a put. All right, so let's get it again. We have this one, but we have more. Since we put 2 items to the DB, to the store, we can get an older version. Just let me clear this one. -v. So this is the first version. This is the second version. So we also have versioning in the project, and I can delete versions as well. So if I do Spike delete tenants Acme DB, it will delete, the most recent version, but I can also provide a version to delete. So if I want to delete the first version, it will delete. And if I want to get the first version, it will say secret not found. If I do second version, it will say there's a secret. Things like that. What else? Let me do Spike again to see what other methods that we have. We demoed delete, get, help, you can use it. We did init, we did put. We can undelete as well. Let me do that. So clear. So we deleted recently the version 1. So if I undelete and then spike get, I'll get the secret again. So right now we maintain a certain set of versions. Like we keep at the moment 10 versions by default. So if you create an 11th version of a secret, the least, the oldest one will be permanently deleted. That number is configurable from the environment variable. Let me show you where it is. Quick start configuration. So it is like maximum secret versions to maintain. So you can, it's by default 10. Come on. It's by default 10, but you can change it to whatever you want by setting up a environment variable. And there are additional API endpoints that we are going to implement to totally purge the secret. So I don't want to even keep the versions. I want to destroy the secret completely. And again, this is HashiCorp Vault's the destroy key value method. It is not implemented here yet. It will be. But yeah, we have versioning, we have deletion, we have undeletion, the basic needs for a practical key value secure secret store. And we also have list. If I do a spike list, I see that I have one tenant as a secret, as a path to a secret. And the reason we use paths is, again, that we can be able to define policies based on these paths. But that's all for the demo, I guess. Like I said, this is a initial project, and it's really exciting to be fair, because this is the first of its kind that is using SPIFFE as its identity control plane, and it is a first-class citizen to SPIFFE. There are other SPIFFE-related secrets management open source solutions, but they don't assume SPIFFE as they are not this intimate with SPIFFE. They assume other primitives like a Kubernetes secret or like a Kubernetes environment or like certain service accounts and an orchestrator to be able to run. This is more generic. It can run anywhere, any place in the known universe, as long as that known universe is also supporting SPIFFE and Spire. But yeah, as far as this initial demo goes, that's all there is to it that I can share. The project, like I said, the website is spike.ist. You are more than welcome to read it and contribute to it. On the website, there is this tiny GitHub icon, link, whatever you call it. And you are more than welcome to go to the project and give us a star. Right now, I am the only star giver. So the more you talk about this project, the more you mention it, you add stars, you add comments and suggestions, the better it will be. So all kind of contributions are welcome, as I said. And we have one release at the moment. It is version 1.0.0. It's the first version, and we have binaries for all of the environment, so that you don't have to recompile Spike if you don't need to. But still, I would go through this entire experience and follow this demo myself if I were, to learn Spike and be a contributor to the Spike project, because like getting your hands dirty is the best way to like get used to a code base. But yeah, that's it. I hope you like it, and I hope you'll be a part of this initiative. And until next time, and until the next demo, keep your secrets secret.